So as you can see, there's a syllabus link which gives in detail the classic science Olympiad syllabus. Then there's a payment link. Then there's a feedback link and all batch details link, which will give you detail about the ongoing and upcoming batches. Then there is a query link, which can be utilized if you want to ask a query. You can drop us an email or you can WhatsApp on these numbers. And in case you are having an unstable connection, you want to watch this demo live on FB, you can do so by clicking on this link. Okay. All right. So now let me quickly tell you about the flow of the session. So first of all, you will get to know your mentor. Then you'll see a short informative PPT, which will tell you about the course that you're about to embark on. Then you'll go on a short virtual tour of the dashboard. And after that, you can ask your doubt in the chat section. We'll be happy to answer. And after all these things, your actual demo will begin. All right. Is it clear? Okay. Good. So let me tell you that we have with us Aishwarya ma'am, who has got this passion for teaching. She loves to interact with kids like you. She's got substantial experience and she's an expert in science, you know. So I'll request ma'am to tell you about herself directly. All over to you, ma'am.
Thank you, ma'am. Hi, everyone. I hope I'm audible to everyone. Yes? No? Okay, great. Okay. All right. So my name is Aishwarya, as Monica ma'am has just mentioned, and I love teaching, of course. That's why we're all here. What I want from all of you when we come to regular classes is to be interactive as much as possible, because that is how we'll all learn, right? So don't feel that any of the questions are silly or any doubt is silly. No question is silly. So we are supposed to interact and discuss as many doubts as possible. Other than that, a little bit about me. So I have an MPhil in botany, and I am currently pursuing my PhD in botany. And I belong to Delhi. So I've been teaching for competitive exams for almost 4 to 5 years now, and I've been associated with Olympiad success also for quite some time now. So I hope we'll have a good and comfortable as well as a great experience together when we come to the regular classes. All right. Thank you.
Thank you so much, ma'am. Now, children, I'll be sharing my screen. Just a moment. So I believe my screen is visible to you all. So very warm welcome to the demo and interaction program for Class 6 Science Olympiad. As you are already aware, Olympiad Success is India's largest online preparation platform for Olympiad exams. Olympiad Success Live is India's first exclusive live classes for Olympiad's preparation. School Plus by Olympiad Success is one of its own kind of annual program that includes 8 important courses, which are mathematics, English, science, logical reasoning, communication, both spoken and written, Vedic math, and coding. So here you get one-on-one online CBSE, ICSE, IGCSE, and IB classes for grades 2 to 12, one-on-one preparation classes for international mathematics Olympiads like SASMO, CMO, HKIMO, TIMO, Math Counts, US Common Core Math Competition, Math Kangaroo, and PRMO. So you can meet our international rank holders for the year 2021-22 on the screen. They're all kids like you. So classes will be group sessions with batch size of around 20 students delivered through Zoom by seasoned tutors. You have already met your mentor, Aishwarya ma'am. So you'll be getting 3 sessions per week. Note down the days and the timings. Mondays, Thursdays, and Sundays. Timing will be 6:30 p.m. to 7:45 p.m. with 5 minutes of break in between. Classes will be a mix of theory, practice questions, doubt sessions, and discussion on previous year papers. You'll get access to reading material, practice questions available in the dashboard. And you can also practice topic-wise mock tests for both maths, reasoning, and logical reasoning. Now, how to access all these, you will get to learn very shortly in the virtual tour. So syllabus is available at this particular link. Fees can be paid by clicking on this link. All the important links have been pasted in the chat box and will again be pasted for you. The fees for this course is 11,151 rupees. It is going to be a 50-session course. And the fees includes online classes, daily reading notes and exercises, practice of previous year papers, and access to Olympiad Success Platform for mathematics and logical reasoning. So all that you require for these classes is a laptop or a desktop with good internet speed, with camera because we do not allow students without video in the class, and headphones for better audio clarity. Now in 21-22, Olympiad Success had students from more than 3,800 schools across India and abroad, hailing from 35 plus countries. Now the live classes for this particular batch begins from Wednesday, 4th of April, 2024. So I hope you've noted down all the relevant details. Now I would request Pooja ma'am to take you through a virtual tour of the dashboard. All over to you, ma'am.
Thank you so much, Monica ma'am. Good evening, everyone. How are you all? Let me share my screen with you. Okay, so hope you all are doing pretty well. Hope my screen is visible to everybody. As you all know, I have given this tour earlier also. What you have to do is you have to just enter this URL on over here, olympiadsuccess.com. So the moment you'll enter this, you'll get this page on your screen. Wherein you need to enter your user details. Make sure that you're entering your correct user details, otherwise you will not be able to log in. Let me reshare my screen. Okay, so after entering your user details, you'll get this personal details on your screen wherein you need to just check your details. If these are correct, that's fine. If any of the detail is incorrect, you need to just correct it and you need to click on update button. All right. So after this, you have to just go on live classes button, which is right after this my referral icon. So over here, you have to select your subject for which specific subject you want to see your worksheets, your reading material, and your question papers and answer keys and schedule as well. Okay. So after this, for checking your reading material, you need to select your topic for which specific topic you want to see all the stuff. So for this, you have to just check the schedule. Schedule will give you an idea that in which session we're going to cover specific which topic. Okay. So this PDF you can download it over here and you can just keep it save in your desktop also device, whichever device you're using for your classes, you can keep it safe there. All right. So this is a holiday calendar, and that will get an idea that on which day we do have festival holidays. So that make sure that you should not take any other holiday. Here is a reading material wherein you can see the set one reading material is here. You can just download this PDF if you want to read this later on. So each and every PDF is downloadable. You have to just click it on this right icon, which is right on the top, on the right hand side of this each and every PDF. Just click here to download the PDF, okay? And it will be easily downloadable. It can be downloaded in your device. So this is set one reading material. This is set two. Now I'll show you the question paper. So here is a question paper set number one. This you can download, take out the printout and solve it because this will give you a more good practice. And make sure that you should not download your answer keys parallelly when you're downloading your question paper because otherwise you will prefer to see your answer keys parallelly. Okay. Solve your paper first, then check your answer keys that how have you done. Whether you have done any answer correct or wrong, whatsoever it is. Okay. So this is the answer keys. Same goes for set two also. Here is the answer. Okay, so this is all about reading material, question paper, schedule, and holiday calendar, which you'll get all these in live classes. So now I'll show you the worksheet which is right after this dashboard icon. Over here again, you have to select your subject for which specific subject you want to see. Science and number also, as many you want, you can see. Okay, so I'll show you how you can attempt this worksheet for your practice. You have to click on Take Exam. While clicking on Take Exam, you'll get these instructions on your screen wherein I want you to read each and every instruction carefully, that you should not commit any mistake while attempting your worksheet. Okay. So after that, you have to just select this icon and you have to click on Start Worksheet. While clicking on Start Worksheet, you'll get worksheet on your screen wherein you can see there are 50 questions in one worksheet, right? So there's a lot of practice. So once you're done with your question, you have to click your answer. Okay. So select your correct answer, and then after attempting your first question, you have to move on question number 2. So for that, you have to click on next button. Okay. Make sure that you read your question properly, then solve your answer. Okay. For moving ahead, you have to keep on clicking next. Okay. So in this way, you have to attempt all your 50 questions, and then you have to submit your worksheet. For submission, you have to just click on this finish button. Before clicking on finish button, make sure that you revise each and every question properly, that you have not submit any mistake according to you. Okay. So that you have to just click on this yes, I have reviewed all the questions. Make sure that you click on finish button, otherwise you'll not be able to submit your worksheet and you'll not be able to see your performance also. Okay, so this is a feedback page. If you want to give there and then only, you are allowed. Otherwise, you can click on later workout button also. Okay, so after this, there's a performance. Now you are curious to see your performance, that how you have attempted your worksheet. Okay, so for that, you have to just click on performance button, which is right after this worksheet button. Again, you have to select your subject. For which specific subject you want to see, you have to select. So you can see I've attempted just now, and I'm checking my performance. I've attempted 2 questions, both are wrong. Okay, so that shows, and you can click on review button also to see which answer is correct and which was wrong. Okay, so this is all about your dashboard. It shows that how you have to attempt your worksheet, how you have to attempt your question papers, how you have to attempt your reading material, how you have to see your schedule and holiday calendar and everything. Okay, so before moving ahead, you have to just log out. Let me stop sharing my screen. Okay, so that was all about dashboard tour. If anybody is having any query related to that, drop it in the chat box. I'll be happy to answer your query. What you were doing at the time of dashboard tour? Movement is not allowed. Ankit Gandhi. And don't bite your nails. That's bad manner. Okay, Ashaz. Yes, but you need to buy this course. Ashaz, can you be a bit more clear with the query?
Pooja, I think he doesn't have a query. He's answering the query of Shakya Chatterjee. Will these be free, the quizzes?
Oh, that's great, Ashaz. Thank you so much for the support. Will these be free? Okay. So hope, Sakya, you got your answer. Anybody else is having query related to that?
Any doubt, anyone? Himaksh, Harini, Dhey, and Navneet, please switch on your cameras. Nice to see you, Harini, Himaksh, and Navneet. Okay. No doubt. Can you tell me the starting date of this batch? So Ashaz, Himaksh, and Shaurya are saying 4th April. Are they correct? 4th April, Noor and Navneet are also saying. Yes, 4th April is the correct answer. Very good. That means you were all attentive during the PPT. Nice to know. So how many sessions will be there overall? $50 is the right answer. Very good, children. So we've got some bright students here? Right. No doubts? No doubts? Shall we go ahead with the demo? Show me a thumbs up. Okay, very good. All over to you, Ishwarya ma'am.
Thank you, ma'am. All right. Let me just share my screen. So for today, we will be discussing the topic sorting and separation. All right. So let me just share my screen with you guys. Before we start, Ashaz, can you tell me which standard are you in? Fifth. So I think it will be better if you attend the demo for 5th grade only. You were there for 10th grade also. Last time I was taking a demo for 10th grade. All right. So I'm just going to remove you from the meeting.
Sorry, ma'am, don't remove him. Okay, I'll let it be. I'll see.
All right. Okay. No problem. Okay, let me just share my screen. Okay, so today we're going to talk about sorting and separation of materials. So when we are talking about sorting and separation, first of all, why do we need to sort out and separate out materials? Is so that we can actually know the different properties of individual materials that might be present in a mixture or in a combination with each other. Okay, so individual properties are always different from the properties of a particular mixture. Secondly, we need to separate out materials just to purify or just to obtain a pure substance. Okay, so for example, let's say you have a mixture of mud and water. All right. Now, of course, you can't drink that muddy water, right? You need to clear out pure water. So at your homes, what do you have? You have a filter system, or you have an RO, or some kind of water purifier that is purifying your drinking water, and then you're able to drink it, right? So that's one technique as to how you will separate out mud from water by using your filtering system. So what does that filter use? How is muddy water being, cleared out for you to drink it? How is it beneficial for you? All those things we will be talking about in this chapter. So before we move on to how do you sort out and how do you separate materials, let's look at different types of materials first. So this is what this chapter is going to comprise of. It will talk about matter, the different states of matter, the characteristics of different states of matter, their different properties, okay, then classification of matter, then properties of different kinds of materials, then mixtures and pure substances, different types of mixtures, properties of mixtures, then necessity for separation and different methods for separation. Okay, so of course, in this demo, I'm not going to cover the entire chapter. We'll do that in the regular classes. So I'm just going to give you an overview of this chapter as to what is matter and what are the different states of matter. I'm sure you must have done this earlier in previous classes also, but we'll go through this one by one. Okay, so what is matter? How do you define matter? Matter is defined as anything that has certain mass and takes up space. So anything around us which has weight and takes up space is known as matter. Okay. Now there is a question given that could you name 2 things that are not matter? Can you put it in the chat box? 2 things which is not matter. Something which does not have mass and which does not occupy volume or space. Anything that comes to your mind? Everything is matter. Okay. Emotions, thoughts, yeah. Correct. Any form of energy, okay, or let's say words, thoughts, correct. Anything that, yes, all your emotions, even energy, that is also not matter. So for example, let's say if I talk about sound energy or light energy, we do not consider them matter, okay, because they will not occupy space and may or may not have mass, okay. So yeah, but everything around us, any solid, liquid or gaseous particle that we have, they are all made up of matter or it's matter, okay. Yes, Akya, vacuum also. Vacuum is not matter, correct. Okay, now there are 5 states of matter. Okay, you already know the 3 states of matter, which is solid, liquid, gas. Okay, there are 2 more states of matter that we will be studying about, which is one, Bose-Einstein condensate, and then we have plasma. Okay, so let's first look at solids, liquids, and gas. So solid, liquids, and gas is represented by these diagrams. So solid particles are very closely attached to each other. They do not have any kind of intermolecular spaces between them. Okay, hence they have a solid appearance. They will have a fixed shape and a fixed volume. Okay, second, you look at liquids. Liquids have slight space between them. So there is slight space between the molecules of liquid. Hence, they can flow a little bit and they take the shape of the container, but they will have a fixed volume. So no fixed shape, but a fixed volume. Air, on the other hand, if you see gases, the intermolecular force between the gases is very small. Okay, or let's say it's negligible. So they are flowing away from each other, or they are very far away from each other. Hence, they do not form a compact structure. So they do not have a fixed shape and they do not have a fixed volume. Okay. Now, before I move on to Bose-Einstein condensate, yes, even fermion condensate is there, Sakya. So fermion condensate, Bose-Einstein condensate, these are all theoretically present, but we have no practical use of it as of now. Okay, but I'll come to that in a little while. Now, if you see here, you see these molecules or the particles of matter. What are these particles? What are these particles that we can see moving around? What are they called? Atoms. Correct. Atoms or molecules. So atoms are single elements, and when multiple atoms combine together, they give you molecules. So here we are seeing atoms. Atoms of different or atoms or particles of different material will give you a solid, liquid, or a gaseous structure. Okay. Now, when you look at these, you see these are moving. They're not stationary, right? That means each particulate matter or each atom has some amount of kinetic energy in them. Okay. So remember this I will talk about in a little while later. So they will be constantly moving. Okay. And when they're constantly moving, they will create space between them if they will get some amount of heat or there's increase in temperature. So remember, whether it's a solid, liquid, or a gas, these atoms are constantly vibrating to and fro around the mean position or around themselves only. And depending upon how much they can move around, they can change state of matter accordingly. Okay. Now, let's move on to plasma. What is plasma? Normally, what happens is when solids are heated, they convert to liquid. When liquids are heated, they will convert to gases, right? Now, when gases heat up, and gases exist at very high temperatures, almost around 5,000 degrees Celsius, they will form plasma. So plasma is very hot gas, and it is hot because of one, presence of ionized material. Okay, so they have a lot of ions in them. They have a lot of charged particles in them. Okay, and they can dissipate out a lot of energy. Correct, Sakya. So sun is nothing but sun is a ball of gaseous material, and sun is made up of plasma. Okay, that is why sun can dissipate out so much energy. All the light energy that is coming to us, all the planets, specifically to Earth, and what all we are absorbing is nothing but energy coming out from the sun. Okay, because plasma has a lot of energy, right? All right. Till here, any doubts? Solid, liquid, gas, plasma? Anyone? Okay, now let's come to Bose-Einstein condensate. So Bose-Einstein condensate is something that is man-made. Okay, and here what happens is, yes, Sakya, what's your doubt? You can put it in the chat box. So what happens in Bose-Einstein condensate is normally when temperatures decrease. So when Gases will lose temperature, they will become liquids. Liquids will lose temperature, they will become solids. And when solids lose temperature, what should happen? It should remain solid only, right? However, we have made a certain gaseous particle which can exist in very low temperatures. So Bose-Einstein condensate are gases that are present at very, very low temperatures. So we have discovered, or let's say we have practically made it, but there's no use of it as of now. So using the Bose and Einstein formula, they have formulated or they have made this material, but we have no use of it as of now. Okay. Yes, Sakya, plasma has ionized energy because there are charged particles present in it. Okay, so they will have ions, both positively charged and negatively charged. Okay. Now we sort out material on the basis of their appearance. That means what is the color, what is the texture, how hard is it, how soft, does it have luster to it, shiny, non-shiny, how does it look like? So all that is appearance. Second category or second way in which we sort out matter is solubility. That means whether it is soluble in water or not, whether it is soluble in a solvent or not. So we can take a particular solvent. It doesn't have to be just water. It can be alcohol also. It can be any other solvent. So whether a material is soluble in a particular solvent or not. So soluble or insoluble. Then whether the material is metal or non-metal. So usually metals, if you look at them, metals are highly reactive materials. They are, their valency is usually 1 or 2 or 3, so they can easily give away their electrons. So that's why they're highly reactive. They are shiny, they are hard. Mostly they are solids at room temperature. Any metal which is liquid at room temperature or gaseous at room temperature? Can you tell me? Gallium is non-metal. Yes, mercury, correct. Mercury is the only metal that is liquid at room temperature. Okay, then we have non-metals. So non-metals are usually non-shiny. Okay, they do not have any kind of luster in them. Most of them can be gases, all right, and they will have the features that are absolutely opposite to metal. So one by one, we'll discuss them in a little bit. Then the fourth category of sorting is light transmission, whether it is opaque, translucent, or transparent. So if it does not allow any light to pass through it, it is opaque. If it does not, it allows little bit light to pass through it, it is translucent. And if it allows all the light to pass through it, then it is transparent. Okay. So different kinds of questions will come on these also. We'll discuss it in a little while. No, Ankit, it doesn't change to solid. It will remain in the gaseous form only. That is why it is a different state of matter. If, okay, Himanshu, I'm just coming to it. If plasma is positive charge. No, it is not necessary. Bose-Einstein condensate has no charge to it. Okay, it is a neutral gaseous particle, and the plasma also doesn't have only positively charged particles. It has both. It can have both negatively and positively charged ions to it. Okay, there are more positively charged ions. That is why it radiates out a lot of energy, but it has both. Okay. All right. So now what happens is we have seen that whenever we can change gas to plasma, yes, some gases, not all gases. That can be done in the lab, yes. Okay, it can be changed to plasma. So you can make plasma in the lab. That can be done. All right. So coming to how change of state of matter occurs. So normally what happens is whenever your molecules are gaining heat energy. So like I said in the previous slide, we saw that the molecules were moving. So what is happening? Molecules is vibrating. Okay, so it has some amount of kinetic energy. Now, when it gains up heat, when you apply heat to it. So let's say I have ice and I'm heating up ice. What is happening? I'm providing heat to it. So where will that heat go? Heat will go into the molecules or the atoms. When it goes into the atoms, what will happen? They will start moving faster. Okay, when they're moving faster, what will happen? They will move away from each other. When they're moving away from each other, there is intermolecular space created between them. When intermolecular space is created between them, they will change their state of matter. So a solid which is compactly arranged gains heat, moves away, becomes liquid. Liquid heated up, more they will move away, becomes gas. Okay. So as you increase heat or as you provide temperature to different states of matter, what will happen? They will keep on moving. The molecules or the matter, the atoms in the matter will keep on moving away from each other, which will create the change in state of matter. So solid will convert to liquid. Liquid, if further heated, will convert into gas. Okay. You remove the temperature. So if in gas, so gases, particles are away from each other, right? You take away heat energy. So what is happening when you take away heat energy? So when gas is cooled down, molecules will move closer to each other. So it becomes liquid. When liquid will lose energy, it will become solid. Now there are certain changes which happens directly. Gas can directly convert into solid, right? Or solid can directly convert into gas. So in those cases, there is no intermediate liquid phase. The particles will either move away or compactly arrange themselves again. So sublimation or deposition happens in that. But the same thing is, like, the main process is that the kinetic energy of the molecules will either increase or decrease with the help of heat. You add it or you remove it. Okay. All right. So this is what happens. So solids, when you add energy in the form of heat, it will convert into liquid. Liquids, when you add energy in the form of heat, will convert to gases. Gases, you add heat, will convert into plasma. Okay. So here you can see, as we increase the temperature, solid converts to liquid, liquids converts to gas. As we decrease the temperature, gas converts to liquid, liquid converts to solid. So here freezing point and boiling point is given. This is specifically for water. Okay. So the point at which liquid converts into solid is known as the freezing point. So freezing point for water is 0 degrees Celsius. As soon as the temperature reaches 0 degree, liquid will convert into solid, or water will convert into solid. And as soon as water reaches 100 degrees Celsius, it will convert to water vapor. Okay. In between, it might just melt or evaporate a little bit, but it will not completely convert itself. So the difference between evaporation and boiling is that evaporation can occur at any temperature. Normally also at 40 degrees Celsius or 30 degrees Celsius during the daytime, evaporation is happening, right? That is how your clothes are drying and everything. But boiling point would be the exact point, or at 100 degrees Celsius, where all the liquid or all the water will convert into water vapor. Similarly goes for freezing point also. So your water, if I take water and I put it in the freezer, it will get colder. It will start to become chill, but it will convert into ice only when it reaches 0 degrees Celsius. So normally your freezers or your, the refrigerators are set at -3 degrees Celsius. That is, the freezer is set at -3 degrees Celsius, so that it remains as ice. Any doubt here? Anyone till here? Okay. So these are the different names that we give, or the terms that we use for phase change. So fusion or melting is solid to liquid. So when a solid melts to liquid, we call it melting or fusion. Freezing is when liquid converts to solid. Yes, yeah, sure. It will become ice at 0 degrees Celsius. Okay, it will become solid at 0 degrees Celsius. Only water. Other components will have a different freezing point. Vaporization or boiling. So vaporization is conversion of liquid to a gas. Condensation is gas to a liquid. And sublimation is solid to a gas directly. And deposition is gas to a solid. Okay. So, yes, correct, Noor. Okay, so here you can see the graph is given. The graph shows the effect of temperature on different states of matter as well as pressure. Okay, so pressure also creates a certain kind of effect on this change of state of matter. So temperature, we can already see if it's at low temperature, it is solid, at medium temperature is liquid, and then at high temperatures, it is gas. Okay. Other than that, if you look at pressure, pressure can have a change in the melting point. So normally when pressure increases, what happens? Your solids or normally, let's say, the freezing point will go up. Okay, so it will allow little bit of extra temperature for you, or you'll have to apply a little bit more, or you'll have to decrease the heat a little bit more so that it converts to freezing point. Okay, so pressure will create that change in the melting point as well as in the freezing point. This can be seen when we cook food in your pressure cookers. Okay, so pressure cooker, when you're cooking your food, what happens? Pressure is applied to the solid and it quickly boils, or it will mash up quickly. Otherwise, if you cook it in an open vessel, you will see it will take a lot of time to cook, or it will take a lot of time to become mushy. But if you're pressure cooking it, then it will become mushy, or it will cook very easily because it will change the melting point, or it will decrease the melting point. Okay. Okay, examples of gas to solid deposition. Okay, I'll tell you. How can we conduct deposition of water in the form of humidity in the air? You cannot convert. Okay, first of all, example of gas to solid, we have different salts. Okay, when we collect salts, salt crystallization is done with deposition. So we vaporize the salt and whatever salt particles are there, we convert it into vapor form, and then we collect it directly as crystals. So that is gas to solid. Okay. How can we conduct deposition of water in the form of humidity in the air? We don't convert water into direct solid. Okay, normally it doesn't happen unless the temperature can be directly, if the temperature is completely decreasing down to freezing point, till then we cannot make solid from gas for water. But other substances can be converted into solids from gases. Examples of gas which can be converted into plasma, any mostly ionized gases. Okay, so if you have, let's say, chlorine gas or sulfur gas or any kind of radioactive gases, they can be converted into plasma. Any gas that has a lot of charge in it, they can be converted into plasma. Water vapor and all you can't convert to plasma. Okay, they will remain as water vapor only. Okay, so this is how it happens. So normally what happens is when we are talking about conversion, or when we are talking about change in temperature, that change in temperature is known as enthalpy of the system. Okay, enthalpy means the term enthalpy means randomness. Okay, whenever we are converting materials into different states, the randomness of the molecule is changing, right? Either it is moving slowly or not moving at all, or vibrating very quickly or not vibrating at all. That is why it is known as the enthalpy of system. So solids converting to gas, sublimation; gas to solid, deposition; solid to liquid, melting; liquid to solid, freezing; gas to liquid, condensation; liquid to gas, vaporization; gas to plasma, ionization; plasma to gas back, recombination. Okay. Now, if you see here, there is some terminology is given. So we have delta H given. What is delta H? Delta H means whenever the symbol, triangle symbol is coming right here. You see there's a triangle symbol here. Whenever this triangle symbol comes, it means change. Right? So change in the enthalpy, it's not enthalpy, it's enthalpy. 1 second. Let me just get this out. So you see here, this is delta H. Delta H means change in enthalpy. Okay. So whenever this delta is coming or triangle is coming, it means change. So change in the enthalpy will cause sublimation. That means change in the heat will cause sublimation or vaporization or melting or freezing or condensation or deposition. So only that thing you need to know. We don't need to go into the detail. This is a part of your thermodynamics, which you will study in higher grades. For now, since the term enthalpy is mentioned, enthalpy is given by the symbol H, and that is the change in enthalpy of sublimation or vaporization or melting or fusion, freezing, vaporization again, and deposition or sublimation again. So 1 is in minus because temperature is decreasing, and this is positive because temperature is increasing. That's it. Okay. This you don't have to know as much as this. So these terminologies will come. Okay. There's no instrument. You simply have to heat it up. Basically, there's a chemical reaction that occurs, Ajas, where the particles will be broken down and ions will be released out of it. Okay, so you don't need a special instrument. Okay. Now coming to different types of matter. So we'll quickly talk about different types of matter. So matter can be classified into two types: mixture and pure substances. Now, pure substances are substances which cannot be physically separated. It can only be separated through chemical reactions. Okay. There are two types of pure substances: elements and compounds. Okay. So element cannot be separated or broken down into simpler forms. An element will exist as it is in the environment. So for example, you have oxygen, carbon, nitrogen, all the elements are mentioned in your periodic table. Okay, so they are the simplest form of matter, right? When elements will combine together, they give you a compound. So compounds can be broken down chemically, not physically. What do I mean by that? For example, an example of compound is water. Okay, water is what? Chemical formula for water. Can someone tell me? What is the chemical formula for water? Correct. It is H2O. Okay. So that means there are two molecules of hydrogen and one molecule of oxygen, right? So can I break it down physically? That means if I heat it up or I boil it up or I put pressure to it, will it break down into hydrogen and oxygen? No, right? I can only separate it out chemically. So how do we separate out H2O and make H and O? Is by passing electricity through it. So electrifying it, and then there are certain chemical reactions that we do, and only then can we separate out H and O from water. All right. So compounds are different elements that are combining together in a fixed ratio. So make sure that you get this correctly. I'll repeat myself. Compounds are combinations of two or more elements that are combining together in a fixed ratio. That means water will always be H2O. Whether I go into space, whether I go in on moon, whether I'm on earth, whether I'm underwater, underground, water will always be water. So there are two molecules of hydrogen always and one molecule of oxygen. Okay. No, it's the other way around. Two molecules of hydrogen, one molecule of oxygen. Okay. If I add H2O2, that means two molecules of hydrogen and two molecules of oxygen. That is not water. Then it becomes something else. It becomes peroxide. Okay. So H2O2 is different from H2O. Okay. So an increase in one oxygen can actually create a massive difference. Because if you look at H2O, H2O is something that we drink and we survive on, right? H2O2, on the other hand, is a peroxide and it's poisonous. You cannot even touch it. Okay. So addition of one oxygen has completely changed the property of this compound. So compounds are pure substances, or it's a chemical substance. Peroxide is a chemical, H2O2. Okay. It is highly toxic and highly poisonous chemical. Okay. So normally when we are talking about compounds and elements, we say that they are pure substances because one, they are fixed in their combinations, and second, they cannot be separated out physically. And even if you make combinations of different compounds and elements, they can usually retain their individual properties. Okay. Now coming to mixtures, mixtures on the other hand are combinations of materials that can be separated out physically. Okay. And they are not present in any fixed ratio. So for example, I want to make lemonade. Now I can add 2 spoonfuls of, let's say I want to make 1 glass of lemonade. So I can take a glass of water. I can add lemon juice to it. And I can add sugar. I can add salt to it. I can add ice to it. I can add as many spoons of sugar as I want, right? I can have it sweet. I can have salty. I can make masala lemonade, whatever I want. So there's no fixed combination to make a lemonade. So that is what mixture is. Okay. So when you're making a mixture, there is no fixed combination or fixed ratio. You can add as many components as you want, and mixtures can be then classified into furthermore 2 types: heterogeneous mixtures and homogeneous mixtures. Heterogeneous, hetero means different, homo means same. So homogeneous mixtures are mixtures that will have same state, or you will not be able to separate out, or you will not be able to see the different particles that are present in this mixture. So for example, I make lemonade. In lemonade, I will not be able to see the sugar crystals or the salt crystals, right? I just see a liquid lemonade and everything is mixed together. So it is in the same phase, all the particles. Whereas in heterogeneous mixtures, hetero means different. So in a heterogeneous mixture, what do you see? You see different particles. So for example, let's say I take sand, I take water, and I take pebbles. It is a mixture, but I can see each and every component separately and I can separate them out physically, easily. So whether it is a homogeneous mixture or a heterogeneous mixture, I can separate them out physically. Any doubt so far, anyone? Mixtures. So normally when we are talking about sorting and separation, we are talking about sorting and separation of mixtures, not pure substances, because pure substances are already separated out and they exist as it is. Okay, we have to separate out the mixtures. Okay, I'm going to give you a quick couple of things. You have to tell me whether it is homogeneous or heterogeneous, or whether it's a pure substance or a, like, you have to classify them. Okay, let's start with water. What do you think water is? Compound, element, homogeneous or heterogeneous mixture? Okay. Yashu, Himaksh, Edge. Okay. What about others? What is water? Is it an element? Is it a compound? Is it a homogeneous mixture? Or is it a heterogeneous? It's a, okay, correct. It's a compound. All right. What about air? Air. Can you all send me a direct message so that everybody can answer? Send me a direct message. Okay. Sakya and Ajaz, all right, I got your answer. Send me a direct message, please. What is air? Is it a heterogeneous mixture, homogeneous mixture? Himaksh, send me a direct message, please, so that nobody copies your answer. Okay, Yashu, I got your answer. Let everybody answer, then I'll let you know the correct option. Yes, what about others? Why others not answering? Okay. And please switch on your videos. Shruti, Shreyansh, Indrakshi, Ryan. Okay. Correct answer is that air is a homogeneous mixture. Okay. So it's a mixture of gases. All right. We have nitrogen, we have oxygen, we have other things. But so we know that there is this much percentage of nitrogen and this much percentage of oxygen and this and that. However, it's not a fixed ratio. It can go up and down. Okay. Particulate matter can increase, smog can increase, your pollution particles or CO2 can increase, right? That is how your air quality differentiates. And however, we cannot see each and every particle separately, right? I can't see nitrogen and oxygen in the air separately. So it's a homogeneous mixture. Okay, let's talk about a pizza. What is a pizza? How do you classify a pizza? Send me a direct message, please, everyone. Yes, Sakya, what's your out? You can put it in the chat box. Yes. A pizza would be a heterogeneous mixture. I can see all the toppings of the pizza, right? I can see your onion or whatever you want to add on your pizza, right? Yes, Sakya, you can put your doubt in the chat box, please. All right. Okay. One last. What about sugar solution? If I take sugar and water and I form a sugar solution, what is it? Okay. Correct. Those of you who answered is correct. Yes, Sakya, we can. We can separate a homogeneous mixture physically. Okay, yes. Sugar and water is a homogeneous mixture because sugar crystals will mix with water easily and give you same phase. Okay, sugar syrup, you will not be able to see the sugar crystals separately. So it's a homogeneous mixture. Okay. All right, so these are different properties of mixture based on which we will separate them out. So first, when we are separating them out, we separate them out by physical methods only. We are not, using chemicals, because if we use chemicals or we make any kind of chemical changes in them, then their chemical properties will differ. Okay, so let's say if I want to separate out sugar and water, I want sugar as sugar crystals and water as pure water. I don't want to alter its chemical property. So that is why we only use physical methods. Second, we look at the properties of the mixtures. That means when the chemical properties of the mixtures are present, they should be same as those of its individual elements. So like I said, when water and sugar is mixed together, sugar should be sugar only when I'm separating it out. It should not taste something else, or it should not look like something else, or its property should not change. Similarly, same thing goes for water also. Water should be water only. Chemically, it should become H2 only. It should not be something else when we are separating them out. So when we are looking at these separations or separation techniques, we have to keep all these things in mind, that we don't alter its chemical combinations. We are separating them in such a way that we get individual components easily. Nothing should be lost. Okay. And third thing is energy. There should be no change in the energy when we are changing or when we are converting its physical form or when we are separating them out physically. That means it should not be very high temperatures or very low temperatures, or you're applying a lot of heat energy, lot of kinetic energy is changing, potential energy is changing. No heat should be given out or taken in. It should be a simple conversion of energy. And then we look at its compositions. That means we look at the substances that are present in the mixture, and they can be mixed in any proportion. So these are ways in which we will check out the properties of the mixture and then categorize them as mixtures or pure substances. So these are some examples. So here, let's again, we've already discussed about water, pizza. What about honey? What do you think honey is? Is honey a pure substance or is it a mixture? And if it's a mixture, what kind of a mixture is it? Or just tell me whether honey is a pure substance or a mixture. Okay, I've got multiple answers. Quickly, everybody answer. Honey. What do you think honey is? Is it a mixture or is it a pure substance? Okay, what kind of, if you're saying mixture, what kind of mixture? Homogeneous, heterogeneous? Okay, I've got all different answers. Okay, homogeneous or heterogeneous? Okay, correct. Honey is a mixture. So it is a combination of 2 or 3 substances because it is made from nectar of different flowers and different particulates. So it is a mixture, but it is a homogeneous mixture. Okay. All right. Next, what about sugar? Sugar, flour and laundry and jello and cereal, you already know. What about sugar? What is sugar? Is it an element? Is it a compound? Is it a homogeneous mixture? Or is it a heterogeneous mixture? Yes. Sugar. Okay. All right. Yashu, correct. What about others? Quickly put in your answers, everyone. Okay. Okay, Harini, correct. It is a compound. Sugars are compounds. Okay. They are in a fixed ratio. Normally, let's say if we're looking at, normally, if you look at different types of sugars, glucose, fructose, sucrose, they have a fixed chemical formula and they are compounds. Okay, made up of carbon, hydrogen, and oxygen. Okay. Any doubts so far, anyone? Yes, no, don't know. Okay. Now let's look at this. Here, if you see, there are two substances present. We have a solvent and we have a solute. And when solvent and solute combine together, we get a solution. Okay. Now, when we, yes, Himaksh, you can put your doubt in the chat box, please. Okay. So now, normally what happens is, if you look at solvent and solute, how do you define a solvent and a solute? A solute is the substance that is being put in smaller quantities. Okay, and solvent is something that is in large quantity. So normally the universal solvent that we use is water. So water dissolves almost everything in it. That is why we use water as a universal solvent. But it's not necessary that solvent is always a liquid. Okay, solvent can be a gas also. All right, and solute can be a gas also. Solute also doesn't have to be solid always. Solute can be a gas also. It can be a liquid also. It can be solids also, depending upon the different combinations. Okay, so there are different combinations given here. Water plus lemonade mix is giving you lemonade. Iced tea plus sugar is giving you sweet tea. Milk plus chocolate sauce is giving you chocolate milk. And boiling water plus jello gives you the jelly. In a little bit there, 1 second. I'm just ending it. I'm just going to end it in a little bit. Okay, yes, Himaksh, how do you distinguish between a compound and a homogeneous mixture? A compound will always be in a fixed ratio. Okay, so for example, sugar molecule, if I have, let's say if I'm talking about glucose, the chemical formula for glucose is C6H12O6. So it will always remain C6H12O6. Okay, homogeneous mixture, on the other hand, have no fixed ratio. Okay, they can be in any ratio, but they will be in the same phase. That means different particulate matter you'll not be able to see separately, but they're in the same phase. Okay. So here I'm going to stop. We will talk about this in detail in the regular classes, of course, when we do this chapter, as well as we will talk about all the separation techniques specifically for heterogeneous and homogeneous mixture. For compounds and for elements, of course, we have no physical methods. For compounds, we have chemical methods, which we will not be talking about here. That's for higher classes. We will only be talking about the separation of mixtures. Okay, so that we'll do in the regular class. Any doubts so far, anyone? Any questions regarding classes or anything else? Okay. All right, great. Okay, then hopefully I'll see you all in the coming classes. Yes, Himaksh, you can put your doubt in the chat box. Others can leave if you have no doubt, and thank you for joining the demo. Hopefully I'll see you all in the regular classes soon. Bye-bye. Bye. Himaksh, you can put your doubt in the chat box. Yes, once you join the course, yes. Himaksh, no. In the middle of the session, you're saying per session, you will 5 minutes, 35 minutes, first class, like first half, and then 5 minutes break, and then 35 minutes. So you'll get a 5 minutes break in between in regular classes. Okay. Otherwise, free mock tests. Once you take the course, you will have free mock tests in for all the chapters. Like ma'am showed you the entire view of the website, no? So those mock tests are all free. Okay. Yes, everything will be provided, Shruti. Material, everything. Okay? It's all on the website once you enroll into the batch. Okay. All right, then I'll see you guys in the regular classes. Bye, everyone. Thank you for joining.